Hi girls, I wanted to do a quick video to help us or to support you in analyzing the data that you collected for the duckweed lab. So here we are. I did an Excel spreadsheet, a little bit more specific than the one I did in class the other day. So one of the things I wanted to remind you was that data analysis is analyzing your data to see what the story is. In other words, every data series that you collect, every experiment that you do, when you collect data, it's an exciting time in an experiment because you really uncover a story. And depending on how much analysis you do, you either get part of the story or more of the story, or you get a small part of it or you get a large part of it. So when we analyze this data, we have to realize that we are really just getting only part of the story because we're really just analyzing it based on two statistics, one being the central tendency or mean, another is the standard deviation. And all of the other ways of analyzing your data, please look at that sheet that I gave you. It talks about what to look for on your graph, things that could happen in your control group, etc. Okay, so let's take a look at what we've got here. What I did first was I set up some data tables just for the control group first, and you can see that my number of cups are here and my number of francs per cup are here. Now, since we didn't start off with the exact same number of francs per cup, what we had to do was calculate a percent change for each cup on day one. So we have 39 francs that we counted on day one. What we're going to do is compare that to the 37 francs we started with. So that 35 will be compared to 34, 47 to 43, 48 to 44, 52 to 50, and 37 to 38. So that we can get a percent change, so that we kind of level out the playing field since we didn't start off with the exact same number of francs per cup. So you can see that I have a formula here in the cell. And what I did was I just kind of entered that in and filled it down. And you've got a mean of 0.05. So we would expect a 5% increase in growth if we were to just start another experiment, we would expect that cups to somewhere be around a 5% increase in growth. So if we had 20 francs, we would expect them to be at 24 by day one if our mean is accurate. Okay, so day two, same idea, except we compared day two number of francs back to also the 37 that we had on day zero. Now your days, depending on what you started with, some groups started, and they had the first day of counting as day one, and they had the number that they started with as day zero. As long as you're consistent and as long as we can understand what you did in your data table, that's okay. So somebody's day zero might be somebody else's day one. As long as you were consistent, I think we can make sense of the data that way. Okay, so here we go all the way up here at day 7. So you'll notice that I calculated the change the same way I did before. The 70 lobes were compared all the way back to the 37 lobes in that particular cup to get a percent change of a 90% increase in growth. Here we had a 100% increase in growth. So yeah, I think we doubled here. So we have in that particular cup. Here we had 0.6, 0.5, 0.3, so we times them all by 100. You can get that idea of percent. So we had a mean percent increase of about 70% in these particular cups, plus or minus 0.3. That plus or minus 0.3 is the uncertainty we have with that mean. And the standard deviation is a tool that helps us determine how far the values are spread above and below the mean. If you have a high standard deviation, which this one is almost close to 50% of our actual mean, because 0.3 and 0.7, 0.3 is, like I said, almost half of the way there to 0.7. So we have a standard deviation that's relatively high, so we might consider our data to be somewhat not reliable because it's a high standard deviation. So just because we have a high standard deviation doesn't mean that we suck or that what we did was bad. It's just the idea that something could have been going on in these cups. And I'm looking at cup number 5 where you only had a 30% growth. Maybe something happened with that cup that's kind of skewing this off. So that's stuff that you can write about in your discussion. So I've noticed in the past that students are, well, I don't know what to talk about in my discussion section, or what do we write about? How do we draw conclusions? In your discussion, this is something that you can refer back to. Okay, so let's take a look at the next group that I did as my example, which was the 100% group, the 100% treatment. And I did the same thing. I have my cups, I have my number of francs, I have my day 1. So I did the same thing. I compared 24 with 23 and then divided it by 23, and I got a percent change of about 4% there. So, and you can see all the way down.
So yeah,
I did the same thing for each day. And don't be afraid if you get negative numbers here, because it's just an indication that you had a decrease in growth rate. You can see here on day 7, I have a mean of negative 0.3 and have a standard deviation of 0.2. Now this is somewhat tricky because you have a negative number here. So you have to go back to adding and subtracting negative numbers. If you take a look at your means, and let's come up first with the difference between the means. The difference between 0.7 and negative 0.3 is 1. Our standard deviation here is 0.2, and our standard deviation here is 0.5. So if we take a look at the difference between the two means being 1.0, and we take a look at our standard deviations as being 0.3 and 0.2, both of them are lower than our difference between the means. And if the two standard deviations are smaller or lower than the difference between the means, it means that it leads you to, you're okay with concluding that your hypothesis, your test hypothesis being that there would be a significant decrease in growth, is supported. It means that your two means are statistically significantly different. Okay, so maybe you want to rewind that and listen to that a couple times in case that it's not sinking in. Okay, I want to also show you, and you're going to do that with each treatment group. You're going to compare the 10% back to the control, the 0.1 back to the control, and you're going to draw your conclusions that way about each group as to whether or not the concentration was significantly impacting the growth of duckweed. Okay, so, or your chemical was increasing, the concentration of chemical made a difference. Okay, so to get your graph for this, for your data analysis section, what I did here was I just put days in the first column, I put your means for the control group in this column, and then I went to 100%. You would do the same thing for 10 and 1. And how you create your graph, you guys are all familiar with Excel. I do just want to point out, and you know what, I think we might have time to actually kind of do this one from scratch. So let's see if we can do that. How I created this graph, and I'm on Chart Wizard, but Excel doesn't have Chart Wizard, the newer Excel, so I know how to do that as well. It's actually not that hard, but let's see if we can do it together here. So I'm going to go up to Chart Wizard, and it's going to ask me what kind of graph I want. I want to do a scatter plot here. In most of your science classes, you are going to want to do a scatter plot. Never connect the dots. We'll save that for little kids in the connect the dot books. Okay, so we're going to choose the scatter, and we're going to do next. Chart Wizard is so wonderful, and you know, sometimes you luck out and you got it, and other times you don't. Okay, so here we go. We have our data range. We have series. We're going to go to series. Our graph looks great, by the way. So our series here, series 1, let's give it a name. That's your control. and we will then go to series 2, and that was 100%. So we'll do that as well, and we'll do the next. And here you can see chart title. We can say duckweed growth in varying concentrations versus time, if we wanted to do that. Okay, your x-axis will be days. Your y value will be number. Oh no, it will be average growth. Average. Let's do percent growth. Okay, and okay, so we'll do next. Okay, so we're gonna do, okay, let's finish it and see what it looks like so far. Okay, so that's great. Now, on the newer version, you can pretty much just right click and it'll ask you if you want to add a trend line to your data. I don't see that happening on this version, so we're going to go up to, let's see, insert, see if I can find it, add trend line. So it's under chart. You're going to add your trend line, and that first one for the control, that looked a little bit like exponential. That looked like the shape of what the points were forming. So I'm going to go ahead and enter that. I think this point here is erroneous there. Okay, so we're going to do the same thing for add trend line for this one as well. That one looked to be a little bit more linear, so we're going to add our linear trend there. So you guys can clean up your graph as well, as far as making sure you have units there. We'll have to average growth, average change of growth, maybe instead of percent, or if you wanted to change these to percents, you could do that, and then your units here would be this would be 80%, 60%, 40%. Okay, so you're gonna have probably 4, 5 lines here on your graph, and that's when you can kind of look at and think of what chemical concentration gave you that toxicity, or the toxicity range for your chemical, because you'll see that it'll decrease by half. It'll be growing half as well as your control. So, or maybe you won't. Maybe your data doesn't lend itself to that type of analysis. So I hope that was helpful, and you can find the Excel spreadsheet, the one that I just used here, on the teacher website under AP Bio, and you can just download it, copy it, and then just add your data into those cells, and the formulas are there, and you can just cut and copy as you go. So I really hope that was helpful. I certainly don't want this to be frustrating. This is the fun part. Okay, so I'll see you in class on Monday, and hopefully we can move on to our other experiment on pill bugs, I think is what we're going to do. Okay, thanks so much.